Hello everyone, welcome to Tutors AM, and in this video we're going to be looking at physics, specifically how to calculate the resultant force acting. So let's say we had this object, let's say this object was our box, let's say this object was our box, and then this box we had one person pulling it in this direction, and that person, let's say, applied 1 Newton in that direction. And then let's say we had two people pulling, one applying 2 Newtons and the other applying 3 Newtons. So if we want to find uh, the resultant force, we first have to find the forces that act on the clockwise side and the forces that act on the anti-clockwise side. So to calculate the resultant force, we first have to sum up all the forces in the same direction. So notice that 2 and 3 are in the same direction, and then we subtract the one that is in the opposite direction. So 1 Newton is opposite to the 2 Newton and the 3 Newton force. So if we're in the same direction, we add, and then if we're in different directions, we subtract. So if we wanted to find the resultant force, this is simply going to be 2 Newtons. Sorry. This is going to be simply 2 Newtons plus 3 Newtons minus the 1 Newton, which is in the opposite direction. So this is going to be 5 Newtons minus 1 Newton. So then the resultant force is going to be 4 Newtons. And then it's going to be 4 Newtons in this direction. In this direction right here. This is where the 4 Newtons is going to act. So let's take it, for instance, we have got another box. We've got another box. Let me just erase this. Let's say we had another box, and then let's say this side we had 5 Newtons. And then we've been told to calculate the resultant force. So since they're on opposite directions, we are still going to apply the same concept. We're going to say 2 Newtons plus 3 Newtons minus 5 Newtons. So 2 Newtons plus 3 Newtons, all this is in brackets, minus 5 Newtons. So 2 plus 3, that is simply 5 Newtons minus the 5 Newtons that we have here. So then the resultant force is 0, because you've got the same amount of force acting on each direction. So then the resultant is going to be 0, because all the forces will be cancelling out. Now let's say we've got forces, because this only applies with forces in opposite directions. So what if the forces were in different directions? Let me just clear all this. Let's say we had, let me just draw, and let me just get myself a nice box. Let's say we had a box. Let's say we had a box. Then on this box, we had a force of 6 Newtons. On the box we had a force of 6 Newtons acting in this direction. This was a force of 6 Newtons, so here we've got 6 Newtons. And then let's say we had another force in the same direction of 4 Newtons. So 4 Newtons is smaller. So let's say we had another force in the same direction, 4 Newtons. And then what if we were given another force acting downwards the box, and this force, and let's say this force was 5 newtons. So since it's going down, let me use a different color. Let's say this was 5 newtons. So notice that with this diagram, you've been given forces that are not on the opposite sides. The forces are acting in different directions. So the best that you can do with such a equation is that first you have to find the forces that will be acting on one side. So once we have got the forces that are on the same side, which are the 6 newton and the 4 newtons, we end up finding a resultant force of 10 newtons. So here we're going to have 10 newtons as a resultant. As a resultant force, once we add up these two, we're going to have 10 newtons. Now, knowing that we've got 10 newtons acting in one direction and we've got 5 newtons acting down, these directions aren't opposite, they are perpendicular to each other. This is one thing that you need to understand, is that these are at right angles to each other. So what we can simply do is that this 10 newtons is acting on the object towards its center, which is somewhere here. So using dotted lines, I can represent that that's where the 10 newton force is acting. Let me just clear this up. Just clear this. Let me just clear that one up. And then let me also erase this 4 newtons, because we've known that there will be 10. Yeah, so we know that we'll have 10 newtons acting in this direction, and then from the same center of the object we have got 5 newtons acting downwards. So these forces are acting perpendicular to each other. So in between here they've got a 90 degrees angle, they're forming a 90-degree angle. So what we're going to do is that from this point to that point, we are simply going to extend this. Yeah, we're simply going to extend this, and then notice that we've got a triangle. And then now, once we've got a triangle, we can simply use Pythagoras theorem, because essentially this is a triangle. We have got this type of triangle. We have a right angle triangle, and then here we've got 10 newtons, and then to here we've got 5 newtons. And then for simplicity's sake, let me just write a standard triangle. Let me write a standard triangle. A triangle with our base as 10 newtons and our here our side as 5 newtons. So now this is where we have to apply Pythagoras theorem. So for us to find the resultant force, which is x, we simply know that x, we know that using Pythagoras theorem, that the adjacent side squared and then in the root gives us a value of x. So this will be simply 5 squared. So this will be simply 5 squared plus 10 squared will be equal to x squared. So 5 squared, that is 25, plus 10 squared, that is 100, is equal to x squared. And then 25 plus 100, that is 125, and then this is equal to x squared, and then the root of that by the root of that. So we end up finding that our x is 11.6 newtons. 11.6 newtons. So what this entails is that the resultant force is 11.6 newtons. So just like that, we have calculated for our resultant force, because we had the force moving in this direction and the force moving in that direction. So for us to find the resultant force, we go to the center of the object and move in such a direction that we form a perpendicular, that we form two perpendicular lines, and then we know that once the lines are perpendicular there is an angle of 90 degrees, then we can simply extend the lines of the forces joining, and then we can simply calculate for the resultant force using Pythagoras theorem as we have done here. If you've enjoyed the video, please subscribe to the channel, and I'll be seeing you guys next time. Thank you very much.